Yeah. Thank you for joining this session on measuring and monitoring. My name is Dominique Ngantia. I worked at this university, TU Delft. I'm going to share this first session on measuring and monitoring together with Jan van der Acker from Wageningen University. Yeah. So we will alternate. I will take care of the first three presentations, then that will be Jan's turn and so on. So I'm no doubt we are going to learn a lot about efforts made worldwide about monitoring and measuring land subsidence. We will travel over 4 continents. We will learn a lot about subsidence above different geology, subsidence caused by different processes. And we don't have that much time, so I propose that we start already with the presentation by Saidin Abdikan. Saidin, yes? And we are going to learn about land subsidence monitored using high-resolution PAZ data and Sentinel-1 data in Turkey in an agricultural zone where the ground is karstic, right? So the floor is yours. You have 20 minutes, including your the question time. So please reserve some time for questions. Yeah. Thank you.
Thank you very much. So I can use this one, this.
Yes, this one, and then if you
want to show something. Yeah, thank you very much. So I'm going to start with the motivation of this study and introduce some of the problem of the area. I'm going to give the details about the test field, the data we used, methodology, and I'm going to finish with the results and conclusion. So the drought and climate change is causing so much problem over the Earth's surface, and in Turkey, because of the groundwater lowering, is causing causing a lot of subsidence over the surfaces. Mostly, this is caused by the dense agricultural applications, and the study area is covering the Konya closed basin central of the Anatolian Turkey. And there are some registered wells, but also there are unregistered wells. This is also triggering the decrease of the water level. So if you check the Turkey in general, we see the mostly the risk is caused by the earthquake. This is showing the fault mechanism of the Turkey, and mainly the center looks safe, but this is in this part the problem is actually the subsidence. And there are 26 sub-basins in Turkey, and one of them is Konya at the center of the Turkey. So our motivation is to check the current situation. We have studied previously with ENVISAT data about 8 years of the region, and we determined that there is a large area is subsiding, and we wanted to update of this situation, what is the current spatial distribution of the surface. Displacement, the ENVISAT showed some displacement about 15 millimeters per year, and this is mostly vertical dominated displacements. And here we are going to use PAZ data, expand relatively a new data, and also we check Sentinel results. And the center is covered mostly the agriculture, and there are also different geomorphological structures like the volcanic formations and sand dunes around the region, and it is mostly semi-arid environment. So the two frames are covering the Sentinel, covered by Sentinel, quite large area, but the PAZ data is the the mode of the data is not so big. It's a bit more limited compared to the Sentinel. And when we check the region, because of the underground water level decreasing and also the geological structure of it, some sinkholes occurring in this region, we can see some previously have occurred the sinkholes distributed at the especially the north of the Karapınar, the city region, and mostly we can see the region is has alluvial deposits. So the data is covering both ascending, descending data. The Sentinel is an C-band, but the PAZ is an X-band data. It has same specifications as the TerraSAR-X data, and here we use both vertical structure, and it is it doesn't have so much archive data from 2019 to 2022. 3 years we have data, and the last 6 years for the Sentinel-1 data. In general, we use the stamps for the deformation analyzers to extract the persistent scatterer, and we used Doris for the PAZ data to create the interferograms and the snap the steps for the Sentinel-1 interferogram generation. And if you check the distribution of the data set, they have less than 300 meter perpendicular baseline, and the temporally here is about 1.5 years the data set, and the results, as we can see here, both ascending, descendings are providing a similar pattern over the region. The cities affected here is the Karapınar, the biggest city in this part. Akkuyu, Hotamış, they are more smaller cities, and mostly we can see the displacements are over the city and also the bare lands. The agricultural parts also not there are. We don't see this signal because there are decorrelations over this region. And for Sentinel, we have 6 years. These are also the temporal baseline is about 3 years here, and again the perpendicular baselines are lower than 200 meters, and they are both have approximately 95 images. We didn't use the all data sets; it would be too much to process. So every, let's say, 1 per month, 24 days, we acquired Sentinel-1 data. And we, as we have larger area, we extracted a bit more displacement compared to the PAZ data. So in addition to the east part of these images, at the west part also we extracted some displacements over the also cities, villages. And there are also some linear structures, as we can see here, which are representing the displacements over the electrical powers, the network of the this electrical powers also extracted, and they are also mostly distributed over the bare lands and cities. For Sentinel data, we also created the composition application using both ascending, descending data and converted vertical, horizontal displacements. And these are also, as we applied a grid approach here to cover both data set, so the area is also not so providing large areas, just the cities and some bare lands also extracted compared to the PAZ data again here. And mostly the cities providing some, mostly the vertical, and there are also some small horizontal movements. For the two locations, we compared the time series of Sentinel, ascending, descending, and also PAZ data. They are showing a similar trend for these two locations, A and B. So PAZ has some also noise compared to the Sentinel-1. The dataset is not dense as Sentinel-1. So the standard deviations of the results also a bit 2.5 millimeter per year for PAZ data. And if you check the results discussion, we examined the current ground stability of this closed basin, and the Sentinel-1, of course, has a larger archive data, so it is providing a bit longer term extraction of these movements. And on the other hand, PAZ data is, even it is covering a small region compared to the Sentinel, there are more points distributed, and the displacement over the sediments and linear infrastructure, solar panels, this kind of details can be extracted also using this data and the outputs. And there are also some real measurements here. We wanted to check, is there any correlation among them? There are some wells distributed here. So one of them is just overlap with the displacement maps, and the correlation is about 0.7 for both ascending and descending. The rest, actually, the results do not cover very well. But we can see they are showing a declining trend, the water level decreasing. And also these wells, some of them are providing quite long measurement, but some of them are quite limited. Also, we will check to the points, the ground points, which can overlap for the same years to make a spatial map of this declining trend of the water level. On the other hand, we also checked the individual interferograms. PAZ here provided some results that we can see small movement interferograms that overlap or spatially overlap the same location, which can be useful for possible sinkhole formation for further. For this part, we acquired some interferograms visible, about 200 meters the size of the circle, but we didn't check the if a sinkhole happened or this region or not for this part, but it seems that we can check this using a higher resolution data. So for the previous studies, the first one is our first study over this 15 millimeter per year, and other study also completed over this part using Cosmos SkyMed and Sentinel-1. They show a bit higher displacement, and now it seems lower, so the deformation looks like increasing and a decreasing trend. Of course, here we used persistent scatter analyzers, which is different than the previous ones. So in general, the current situation we extracted using persistent scatter interferogram, and the PAZ data showed some good results. Here, providing a bit larger PS density, and an up-to-date maps are provided using both C-band and X-band data. There are some also limitations as the crop type changes, which is causing the decorrelation, and the PAZ is providing some small area for the all closed basin. We need also some additional frames, which needs a bit more processing. And the location of the well measurements, they do not overlap very well with these results as we applied PS INSAR analyzers. So next goal, we are going to start a small baseline approach, which is expected to provide a bit larger spatial distribution of points and displacement. And for the PAZ, we didn't apply it the conversion of ascending descending to provide the vertical displacement, and along over this we are planning to do applying PAZ data, especially for the sinkhole formations. And as it has similar properties with terracerics, they can be combined and reduce the correlation and improve the temporal resolution lower than 11 days. Well, thank you for the listening.
Yeah, thank you for your presentation.
Thanks.
Nice fair comparison between PAZ and Sentinel-1 data. Thank you.
Yeah, almost.
I'm sure that there are some questions. Yes, Ramon?
Yes, thank you for your presentation, Saigen. I was wondering, so with the INSAR you get a spatial view, a spatial map. Do the spatial patterns that you see, do they make sense? Is that, do you know something about the aquifers or the locations of groundwater extraction? And do you know anything about the depth of where the water extraction comes from?
No, not yet actually, no. They make sense with if you compare the previous results of the other studies. So spatially they overlap with each other, but yeah, we didn't still check the geological.
Okay, and the rates, because I saw you had up to 6 centimeters per year, right? That would mean within 20 years more than a meter of subsidence. That would sound like, you know, a catastrophic thing where you have lots of damages everywhere, right? Is that also something that you see in the area?
In the area, yeah, you don't see so high parts. Some parts you can see that kind of half-meter displacements.
Okay.
Yeah, there are also, as I mentioned, standard deviations of especially the PAZ is a bit high compared to the Sentinel-1. It's about 2.5 meters. So
thank you.
Error is included in the results.
Thank you for the discussion. Burning question? If not, because we are already late in the schedule, sorry. Thank you. Saidin?